Thank you for being part of our study on engineering mathematics by Dr. Emanuel. This is Determinants, lecture number 6. When we talk about determinants, we use determinants a lot, especially when we're going to be using inverse and when we're going to be solving for the value of our particular as we go through it, we will be able to see lots of things. Okay, starting off here with determinants, we can see here we have a 2 by 2, 2 rows, 2 columns. That's called the 2 by 2. So the first is referring to the rows, number of rows. The second is referring to the number of columns. When we talk about determinant of A, we have the absolute value here, which looks like an absolute value, which is going to be a whole number. We're going to multiply by diagonal A times D, and then we're going to subtract the off diagonal B times C. Only applicable to square matrices. A square matrices means that they have the same amount of rows as the same amount of columns. And this provides useful information for us. We talked before about if this is a 2 by 2, this will be like an X and a Y. Okay, so these will be the X and the Y for the first equation and X and the Y for the second equation. Okay, now this is a unique solution if and only if the determinant is not 0. So the determinant cannot be 0. That's not useful to us. Inverse exists if and only if the determinant is non-zero. So you dividing the inverse by, the inverse is going to have a denominator of the determinant. So if the determinant is 0, then that goes to infinity, so it's non-useful. Determinants provides area, volume scale factors for coordinate transformations. And we'll deal with that in chapter 5. Okay, when we're talking here about determinants, we're talking about a minor area, which is this here. And as you can see here, we have our A. And this particular matrix is a square, and it has 3 rows and 3 columns. Okay, so your I represents the rows and your J represents your columns. Okay, the determinant of a matrix you get by eliminating row I and J and the column J. So if I'm interested in this particular one, IJ, if I'm interested in this point here, I will eliminate row 1 and column 1. And I'll just be left with this area. And that's what we're calling our minor. Okay, as you can see here, this is related to these values here, 1, 1, 1, 3, 3, 1, 3, 3. So that means you're using this value here. What? A22. This is called M22. So what happens? The second row is eliminated and the second column is eliminated. So that leaves you with a A11, a A13, a A31, and and an A33. So these are called what we call, that goes outside, we're going to call this cofactors times the minor. Okay? Also known as the signal minor, the signed minor, sorry. Okay, so we have this determinant, and what are we going to be doing? We're going to multiply it times A11 times C11, A12 times C12, A13 times C13. And so what do we get? We get here A11 times this area here minus A12, so you alternate from plus to minus. Okay, and now you're going to, this one here, so now you're going to eliminate this one and this one, so you should only come up with these areas here. And then you're going to do a plus for 1, 3. And with 1, 3, you're just going to be left with this area here. And that'll be added. And then when you multiply, you're going to multiply the diagonal, as we said, minus the off diagonal. Okay? Times the, what we said, cofactor. And then we subtract it. Remember, the second term will be subtracted. Same thing. Diagonals multiplied and across off diagonals are subtracted out. The same thing with number 3. We have what? A13, and we're going to look at what? At this area here. Okay? So we're going to multiply A21 times A32 and minus A22 minus A31. Okay, so with that being said and done, what happens when we have an n by n matrix? Okay, that's an infinite number of matrices. We just looked here at a very small number of matrices. Okay, and so we're going to use the same factor. Remember the A? Okay, times that cofactor. Okay, and we're going to sum them all up. Okay, we can choose any I row, also works on our columns. Now notice here, if you notice here, all of these in the diagonal are all positive, and these are off. This is positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, and it goes that way. So all the odd numbers, okay, are going to be negative, and all the positive numbers, the even numbers, are going to be what? When you add them up, is going to be positive. So if you could take that, depending on the negative one, you can do a check. They call it a checkerboard. Okay, so now that you've been able to do that, can you find the determinant for this particular matrix? So why don't you try it, and we'll be right back. Okay, we're back. All right, so this is how we're going to make this determination. You see this here? We're going to use this and pull this out front as our cofactor, and then we're going to use everything that's left. We're removing 1, 1. Okay, so we're going to keep all of these. So if you see, all of these are in here. Then we're going to take the next one, okay, and then we're going to multiply by percentage times 0 minus 0. We don't have to do anything. So then we'll move to the next one. Then it'll be a plus 1, and then this one will take these 2 here, these here, these 3s here, as you can see, 1, 2, 3, and then we'll take the last row over here. Okay? Then, since this is plus, minus, there's your minus, and here's your minus 2, and then you're just going to take this little corner here. Okay? And so, what happens when we multiply these? Okay, let's see. Okay, what we find is we're going to do a 1 times, now we're going to do this again. So we're going to take this 4 as our cofactor, put it out front, and now we just remove the first row and the first column and just be stuck with this little square here. Okay, then this one is times 0, so that can, this right here is 0, and then this one is 0. Let's move to the next one. Okay, this is 0, so we'll eliminate that. This one is still times the what? The 1. And so the first one we deal with here is 0. Okay, now we have a 4. Okay, so the 4 is going to be these two here and these two here on the end. Okay, then we have again, this one is going to be 0, so we have a 0 here. Now we're going to plus this because it's a minus times a minus equals a plus 2. Okay, now we're going to use this first one as 0. Okay, then we have here, since this is plus, this is a minus, so this is going to be a minus 4 that comes out here, and we're going to have these two here, and then we're going to have these two here. Then we're going to multiply times 0 again, so then that all equals 0. Okay, so how do we work that? Okay, so the next obvious things that we want to do is we want to take this 1 times the 4, and here it's 2 times 2. Okay, this is 0, this is 0, so then we have 1, okay, times what? This is going to be times a 0. Okay, then we're going to have, okay, you have 2 zeros here, so this all goes to 0. Okay, so that's your 1 times all of this is 0. Okay, then you have your 2 here. Bring your 2 down, and you have a 0 and your minus 4. Okay, and you have this times this is what? 0 times 0 minus 1 times 2 plus 0. Okay, so this is going to leave us with 2 times 2 is 4, times 4 is 16, plus 0. Plus we have here what? A minus 4 and a 2. Okay, and then we have another minus 2 here. So minus 2 times a minus 4 gives you what? A plus 8. Minus times a minus is a plus. Times 2 is 16. Okay, this is account for the 0. So what is our answer? Yes, 32. All right. We're moving right along. Okay. What about for determinants equal to 0? Under what conditions will determinants equal to 0? All elements of any row or column are 0. Okay, all the elements of a row or column. Okay, so this is an example of a row which is 0. So there's 0 times 2 is 0, 0 times 1 is 0. So if you had 2 zeros here, it would be 0 times this number and then 0 times this number to give you. So you can see that that is true. Okay, 2 columns are identical. Okay, so if you have 2 times 1 minus 1 times 2, what do you get? 0. Okay, that means that these are the same equations in essence. Okay, 2 rows or columns are proportional. Okay, let's look at this. Okay, this is 1 and 2, and then you multiply this times 2, you get 2 times 4. The reason why this is 0 is because these are the same equation. They're parallel to each other. Okay, these are the same line, so you get 0. You don't get anything. Okay, because it's the same line. These are parallel to each other, so they never intersect. Because they never intersect, you get the same answer. All you have to do is divide this by 2, and that means you're back to what you started here. Okay, interchanging 2 rows or columns changes the sign of the determinant. All right, let's look at an example like that. Okay, so if we have 1 and 2, 3 and 4, and then we switch them and put 3 and 4, 1 and 2, what do you get? Boom. Okay, let's look at that. 1 times 4 minus 3 times 2, you get 4 minus 6 equals a negative 2. Now, what if we take this determinant of the other one, we look at 3 times 2 is 6, 4 times 1, the minus for that, so 6 minus 4 equals a positive 2. So as you can see, the signs change. Okay? The value of a determinant A is unchanged by row reduction. So we can reduce the rows as many times as we want. If we want to take the transpose it, should be no problem. If we want to multiply it, when we do multiplication times a constant, that should be no problem. As you can see here, if you wanted to multiply it by another determinant of another matrix, you can do that. Okay, now let's use row reduction for an example. Okay, let's good example. Okay, we want to subtract 2 times row 2 from row 1. Okay, let's look at row 2, and we want to look at row 1. Okay, if we take row 2 and we multiply it times 2, and we put a negative in front, so this would be 2 times 1, negative 2, this goes to 0. Okay, we multiply this times 2. Okay, we get a positive 2 because it's a negative. Okay, 2 minus 3 is negative 1. We multiply this by what? 2 and subtract it, we get 0. And when we multiply this by 2, we get 4. And we subtract it, so that's 4 minus 5. 5 minus 4 gives me 1. So as you can see, we got 2 zeros here. And that's good. We want to get as many zeros as we possibly can in here. So as we saw before, they just all drop out. So let's try another row. Let's subtract 3 times row 2 from row 3. Okay, let's look at this. All right, row 3, 3 times 1 is what? 3 subtracted, get 0. Okay, we have 3 times negative 1 is a negative what? 3. And so a negative 3, and then you're going to multiply because you're subtracting. So that'll turn into a positive 3, and that'll give you 5. Now we multiply times 3 times 1, we get 3. Okay, and without 3, we have a negative 3 because we're subtracting it. So that'll give us a negative 1 from our 2. And then we're going to multiply this times 3. That'll give us 6. And that'll give us a negative 6, positive 6. It'll give us a negative 6 here. And then that will give us a 1. Negative 6 minus 1 is going to give us a negative 5. Okay, this should be a negative 5. Okay, so the next step, what we want to do, we want to subtract row 2 from row 4. Okay, the row 2 from row 4. So if we subtract 1 from 1, we get what? 0. Make this a negative 1 times a negative 1 gives us 1. That gives us 2. We have a negative 1 here. Okay, so that's a negative 4. We have a negative 1 here. That'll give us a negative 3. So let's see what does this look like. Okay, so now our determinant has changed. Okay, I didn't correct that here, but I corrected it here. Okay, so we do have our negative 5 here. Correct. Okay, so which values? Okay, we look at these again. 0, minus 1, 0, 1. 0, 5, minus 1, minus 5. This is corrected. 0, 2, minus 4, minus 3. And then we're just going to use this particular one here. 1, minus 1, 1, 2. Now, what happens to our determinants? Notice this here, we got what? 1, 2, 3, 0. That's perfect. So that means all we're going to have is one value. This value here multiplied times this one. That's the way we want to do it. okay? So you always want to get as many zeros as you can, which we did, okay? And then what are we left with? We're left with just this area here. This little corner here, and that's what we put right here. Okay, so now we have to multiply all of this again. Okay, or we can do, reduce it again and get some more zeros. Yes, let's get some more zeros. Add 5 times row 1 to row 2. So if we add, multiply this by 5, a negative 5 and a 5 gives us what? 0, another 0, excellent, there we go. And now we have here 5, okay, add 5 times, okay, so this here, 5 times 0 is 0, so what do you get? You just keep a negative 1, then you have a 1 here, you have a what? A negative, what? A positive 5, so now a positive 5 and negative 5 give you 0, so now we got 2 more zeros, yes! Let's keep going, man. We got to get some of these zeros out. Yes, that is perfect. Okay, so now we want to add 2 times row 1 and then add that to row 3. So let's look at 2 times row 1. Okay, so that'd be 2, a negative 2 and a positive 2 gives you a 0. Now we have 2 times 0 is what? 0, so we keep our negative 4. And then we have a 2 here. Is that right? And then we subtract it from 3, and what do we get? We add 3, 2 minus 3 is a negative 1. So now we should have some real good stuff. Okay, now remember, we still got this negative 1 that we're multiplying times everything, so let's make sure we don't lose any terms. So look here, we can get rid of what? 2 of them, yes. And all we're going to do is use this one, and we'll use this specific box. Yes! Perfect! Just what we want to see. 0, 0, okay? Still times the negative 1. And then what do we have here? Okay? We multiply, okay, this area here, our minor, okay? And then what do we get? Okay. This goes to 0, so we have a negative 1 times the negative 1 gives us what? A positive 1. Remember, we had a negative 1 here before, okay? Let's not forget our negative 1 again, okay? So this gives us a negative 1. So this is a negative 1 from this contribution. And this one here, which we're using here, is a negative 1 for our contribution. This times this is a what? Is a positive 1. Okay, so we have 1, 2, 3, 4. What? 4 negatives. Okay? And so because we have 4 negatives, then this should be, because this times this is a positive. Okay? Then we had a negative 1, and it seemed like I dropped that 1. Okay, so this will be a positive 1. Okay? You got to be very careful. As you can see, you'll be dropping negatives all over the place. All right. Well, thank you. I appreciate your sitting in and listening to our presentation, and we'll be back.